Okay, this is a Tuf-Skin butterfly valve on a display stand. We got a 10-inch today on a OM actuator. The cover's off of the actuator so we can show you what's going on inside and demonstrate how these work with relays. The actuator we stock is 120 volt AC. So we got 120 volts AC coming into a simple light switch to use as a safety cutoff. Then it goes into the actuator, and we have the neutral going to directly to the actuator, and the ground going to the ground. And then the hot wire, in this case, is coming up into a relay, and the relay is switching the power back and forth and telling the actuator to open and close. And this is the control voltage coming into the relay, the red and blue wires in this case, coming to the A and B posts on the relay. This is the relay. Also inside the actuator is the motor, the capacitor, and a heater. The heater is on a thermostat right there. That little black thing is a thermostat. And if you wire power up to the heater on terminal post over here, then when the temperature drops below, I think it's 72 degrees, the heater will turn on, and that helps prevent condensation inside the actuator housing. The thermostat turns it off once it gets up warm again. And also inside the actuator are limit switches, limit cams. You adjust those cams to stop the travel on those micro switches. And let's show you how the relay works. The relay, we can get different voltages. In this example, we're using a 12 volt DC relay, but the relay inside has a little switch on a electromagnet solenoid type situation, where when you turn the relay on and on, energize the relay on and off, it switches the power back and forth from open to close. So that would be closing the valve, turn the relay on, it switches to open, and you can switch it back and forth, open, closed, open and closed. And that's in the closed position there in this case. And for power, we're just using, on the test bench, we got two switches, 120 volt and 12 volt DC coming in. 120 volt on this side, the relay voltage on this side. So the valve is about half open right now. So with the relay off, if we turn the power on, the actuator will close. And when the little cam hits the limit switch, it will stop moving. Now, if your controller sends a 12 volt DC signal to that relay, the relay will switch the power and the actuator will start opening. And again, when the limit switch for the open side engages the micro switch, the valve will stop moving and it will be in the open position. So turn the power off, relay on and off will do nothing. One thing to note is that it's okay for your system to turn the relay on and off and on and off. But if you go on, off, on, off, on, off really fast, then you will probably fry the relay. It will arc electricity and weld itself and fry it. So don't do that. We stock 12 volt DC relays, which is common on sand media filter systems to have a 12 volt DC controller. We stock 24 volt AC relays, which is common on most standard irrigation controllers. We also have 120 volt AC relays so that your pump panel can send a signal to open and close the valve. We have other voltages available. 12 volt DC latching if you're using a latching solenoid type situation. Call us if you need more information.